We're going to take a look at two-factor ANOVA with Kij equal to 1. Two-factor ANOVA looks at statistical tests that have two independent variables, also known as factors. Each one of the factors also has multiple levels to it. In this example, you can see that factor A is material and factor B is supplier. Now going a step further, you can see that material is separated into wood, metal, and plastic. You will also see that there are two different suppliers. The levels for factor A, which is material, will be denoted as level I, and levels for factor B will be denoted as level J. The table shows that 6 possible outcomes since factor A has 3 levels and factor B has 2 levels. In the engineering field, you can use this not only to conduct material testing, but also to look at strength and stress tests. Another use of this could be for agricultural engineers looking to compare different types of seed with different types of fertilizers to increase their crop yield. There is a null and alternative hypothesis for both factor A, material, and factor B, supplier. The first null hypothesis states that the different levels of factor A have no effect on material strength. The alternative hypothesis states that at least one of the levels, wood, plastic, or metal, has an effect on material strength. The same formula applies to the hypothesis testing for factor B, supplier, except it looks at the effect that the different suppliers have on material strength. Next, we look at the ANOVA table. The ANOVA table is used to calculate values to help determine the level of significance and to draw conclusions from your hypothesis testing. The sum of squares is calculated in order to see how dispersed your data points are. In other words, it looks at the deviation of data points from the mean. The further away a data point is from the mean value, the larger the sum of squares will be. The mean square value is a calculation that uses the sum of squares and the degrees of freedom to help determine the variation between your data points. Once you calculate your F value, if it is larger than the F statistic, then it is statistically significant and you will reject the null hypothesis. When doing two-factor ANOVA testing, you want to determine if there is any interaction between your two factors and whether or not the factors have a main effect. The examples I am showing have factor A, which is material, on the x-axis, and factor B, which is supplier, as the lines. From the first picture on the left, there would be no interaction between the two factors, but there would be a main effect for factor B. You can determine there is no interaction because the two lines do not intersect. Factor B has a main effect, though, because the average of the supplier 1 is higher than supplier 2. Factor A in this example is not significant because the average of the different types of materials is equal across the graph. The second picture shows no interaction between the two factors, but both factors have main effects. The lines do not intersect, and the averages of the materials are different, meaning factor A is significant, and the average for the two suppliers are different, meaning factor B is significant. The last example shows that there is an interaction between the two factors, but there are no main effects. The interaction means that the type of material and the supplier have a combined effect on the dependent variable, which is in this case is material strength. Lastly is works cited.